What if everything we know about reality is just a fraction of what truly exists? Imagine a universe not confined to 3 dimensions of space and one of time, but stretched across 11 dimensions. Sound like science fiction? It's not, it's science, and it's called string theory. This revolutionary idea suggests that the very fabric of the universe is composed of tiny, vibrating strings of energy, operating in a multidimensional framework. But here's where things get even stranger. Could these extra dimensions be proof that we're living in a simulation? Stay with us as we explore one of the most mind-bending concepts in modern physics and philosophy. By the end of this video, you might never look at reality the same way again. For centuries, our understanding of reality has been limited to the observable universe, what we can see, touch, and measure. But as physics has progressed, so has our perspective on reality. String theory, developed in the latter half of the 20th century, presents a groundbreaking idea. Reality might consist of 11 dimensions. At its core, string theory seeks to unify the 4 fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces, into one theory of everything. According to string theory, all matter and energy are composed of tiny, vibrating strings, much smaller than quarks or electrons. These strings vibrate at different frequencies, determining the particles they form. However, these vibrations only work within a universe of 11 dimensions, 10 of space and 1 of time. While most of these dimensions are curled up and imperceptible to us, their existence could explain many mysteries of the cosmos. This concept is not just theoretical, it has implications for our understanding of reality itself. If we're confined to a 4-dimensional perception, but the universe is 11-dimensional, are we experiencing an incomplete version of reality? And if the universe is fundamentally governed by such a structured framework, could it be evidence of a programmed design, a simulation? String theory has moved from an abstract idea to a growing area of exploration in physics. But it's not without its challenges, and these are what we'll explore next. The idea of an 11-dimensional universe is captivating, but it introduces a series of profound challenges. First, detecting these extra dimensions is nearly impossible with current technology. These dimensions are theorized to be incredibly small, curled up at the Planck scale, a length so tiny that even our most advanced instruments can't observe it. If we can't detect these dimensions, how can we confirm their existence? Second, string theory itself is still mathematically unproven. While it elegantly explains many phenomena, it requires complex equations that often yield results we can't test or replicate in experiments. Without experimental evidence, some scientists argue that string theory leans more toward philosophy than science. Another challenge lies in its implications for our understanding of space and time. If the universe is fundamentally 11-dimensional, then our perception of a 3-dimensional world might be akin to viewing a shadow. It's real, but it's not the full picture. Does this mean we've been living with an incomplete understanding of reality? Finally, there's the philosophical problem. If the universe is designed with such precision and complexity, does that point to the existence of a creator or programmer? And if so, does this mean our reality is a simulation? The very idea challenges our notions of free will, existence, and purpose. Understanding the challenges of string theory and the concept of extra dimensions is crucial to grappling with its implications. Next, we'll delve into how these 11 dimensions could fit into our understanding of a simulated universe. Let's dive deeper into the connection between string theory's 11 dimensions and the possibility of a simulated universe. In string theory, extra dimensions aren't just theoretical, they're essential. The math behind vibrating strings only works if the universe operates within 11 dimensions. The 6 extra spatial dimensions beyond our familiar 3 are thought to be compactified or folded into tiny spaces so small they're effectively invisible. This structure might remind us of how simulations are programmed. In a video game, for instance, a highly detailed 3D world can be encoded within lines of 2D code. Could our 4D reality, 3 dimensions of space, 1 of time, similarly be a projection of a more complex, higher dimensional framework? One compelling argument comes from the holographic principle. This idea suggests that the universe's information could be encoded on a lower dimensional boundary, like a 2D surface projecting a 3D reality. This principle aligns closely with how simulations operate, where complex systems arise from simple rules. Another connection lies in computational physics. If the universe's fundamental laws are based on vibrating strings, then it might resemble a computer program running on a set of precise algorithms. The presence of these extra dimensions could indicate the code governing our universe's behavior. The implications are staggering. If reality is based on 11 dimensions, are we simply interacting with a user interface designed for our limited perception? What lies beyond our view? And could the structured elegance of string theory point to intentional design, a simulation? Here's the key moment. String theory's 11 dimensions might not just explain the universe, they might prove it's a simulation. Recent advancements in quantum mechanics and cosmology have revealed phenomena that suggest a structured, almost digital nature of the universe. For example, the discovery of quantized energy levels in atoms, or the behavior of particles in quantum entanglement, aligns with the idea of a programmed universe. One of the most intriguing ideas comes from simulated physics experiments. Scientists have proposed that if the universe is a simulation, there might be detectable limits, like a maximum speed, the speed of light, or minimum size, the Planck scale. These limits resemble constraints in a digital system where finite computing power imposes boundaries. Moreover, if string theory is correct, and the universe requires 11 dimensions to function, this raises the question, why 11? Why not 12 or 15? The specific number and arrangement of dimensions seem deliberate, almost as if programmed. Could this precision be evidence of a creator or a programmer? And if the universe is a simulation, what's its purpose? Are we an experiment, an entertainment, or something beyond comprehension? These questions challenge not just science, but our understanding of existence. String theory and its 11-dimensional framework open up a world of possibilities. From its quest to unify physics under a single theory of everything to its potential evidence for a simulated universe, this concept challenges our deepest assumptions about reality. We've explored how these extra dimensions might exist, why they're crucial to the math of string theory, and the profound implications they hold. Whether you view the universe as a natural construct or a programmed simulation, the elegance of string theory invites us to rethink our place in the cosmos. Yet many questions remain. Can we ever detect these extra dimensions? Will string theory ever be experimentally proven? And if the universe is a simulation, who or what created it? As we continue to push the boundaries of science, concepts like string theory remind us that reality might be far more complex and extraordinary than we ever imagined. What do you think? Is the universe just 11 dimensions? And could string theory point to evidence that we're living in a simulation? Let us know your thoughts in the comments below. Don't forget to like, subscribe, and hit the bell icon to stay updated on our latest explorations into the mysteries of the universe. If this video intrigued you, check out our other content on the holographic principle, quantum mechanics, and the simulation hypothesis. Keep questioning, keep exploring, and we'll see you in the next video. Thank you for watching.